Here we have another exercise that asks you to draw a finite state machine which will accept all strings over the alphabet 0, 1 and for which each one is preceded by a 0. And also the number of ones is even. So we have two conditions here. We have no ones, 2 ones, 4 ones. So the number of 1 may be 16, maybe 32, maybe 100, okay? But it's not odd. All strings with, for example, 7 ones or 9 ones or whatever the number is odd, the string will not be accepted, okay? And the other condition states that each one, if there's a 1, it should be preceded by a 0. Let's write some examples of these strings. Let's say here 0, 1. Okay, 0, 1. This one is preceded by a 0, so the first condition is there, but the second one is not satisfied. We have only 1 that appears there and the number of 1 is odd, so this string shouldn't be accepted. We may write here not accepted. If we put now 1 and 0 and 1, we will see that we have 2 ones, the number is even, the second condition is satisfied. However, the first condition is not satisfied since the first one here appear directly without a 0 that precedes it. So this string also will not be accepted. Okay, we will accept only strings where we will find a 0 before each one, another one, a 0 before each one, 2 ones, and each one is preceded by a 0, this string will be accepted. Also, if you will write 0, 1, 0, 1, 0, whatever the number of zeros at the end, this string should be accepted because the two conditions there are satisfied. You will also accept 000, and double or 5070, whatever the number. We have at least 1 0 that precedes this one, so we'll accept. Also, if we have another one in the string, it should be preceded by a 0, and we should have the fourth one, so this string will not be accepted. Okay, we should have another one. I will write the same string with the second one and the third one. I need the fourth one and with at least a 0 that precedes it. So in this last string we have 4 ones, the number is even, and each one is preceded by a 0. Okay, so we need to check the two conditions. Now to draw the FSM for this, let's take this example. Okay, the first string here will be accepted. We will write the initial state A, for example. We shall have a transition with the alphabet 0 that goes to another state B, and from the state B I will go to another state C with 1. So we have now 0, 1. C shouldn't be the final state because I need another 0, 1. I will write another 0 here and another 1 here, which go through state D and state E. Here the state E may be final. Okay, it's correct to put this state final because when we reach the state E, we will recognize 0, 1, 0, 1. Okay, so E is accepting here. Now let's say that we may have other ones. If we will add, for example, other ones, the number should be, like I said, even. So we have 2 1 here, and the second part of the string we have another 2 1. So from E, for example, we can think about going back to the state B. Okay, we will go back to the state B with 0. Why with 0? Because I need a 0 that precedes this 1. Okay, so let's say, for example, I have the string 0 1 0 1 0 1 0 1. Okay, I will go from A to B with the first 0, to C with the 1, to D with the 0, then to E with the 1, okay, and then to B with the 0, and again to C with the 1, and again to D with the 0, and to E with the 1. And here we can find, we can see easily that the string 0 1 0 1 0 1 0 1 is accepted, since I will finish all characters and we will find ourselves in the state E, which is final state. Okay, you can think that if I have 6 1, I will go back to B, then to C, then to D, then to E, and we will be able to recognize the 2 next ones in the string, and also each one is preceded by a 0. The first one and the second one are all preceded by 0, and we will go through this loop n times. Okay, if n equal for example 4, n times we will go here, so we will have n multiply 2 8 ones. Okay, if you have 10 ones in the string, you will go through this loop 5 times, and so on. So here we assure through the loop that every time I will go back to E, to the state E, the number of 1 will be even. Now let's go to generalize about the zeros. Okay, we say that before each one I need a 0, but I will accept more than 1 0. For example, here we have 3. If we want to accept more than 1 0, we can add a self loop here on B, okay, with 0. This self loop assures that we may have other zeros before each one. Also here in the state T, we can add a self loop with 0 that will permit to put any number of 0 before any one that will be encountered. Okay, another thing here, if the string contains only zeros without 1, or if the string contains 0 1 0 1, and at the end I will have many zeros. Okay, to accept this kind of strings, it's sufficient here to say that B also will be a final state. Okay, the state B here will be an accepting state in order, for example, to accept 0, 00, 4 zeros. Okay, for 0 I will go through 0 through A to B, and the second one, if it's there, I will go through B another time. If I have 4 zeros, so the first one I will accept it by going from A to B, and the 3 other zeros will be accepted through going 3 times through the state B, B to B. Also, at the end of a string in which we have ones like this, and at the end we have too many zeros, we can say that we will go from A to B, B to C with the first one, C to D with 0, D to E with the second one, and if there is a 0, I will go to B and accept in this state. If there is second 0, I will go from B to B and I will accept. If there is 10, for example, other zeros, I will accept them through being in the state B, and at the end it will be an accepting state. Okay, so here you are with a finite state machine that accepts all strings for which each one is preceded by a 0, and also the number of 1 is even. Okay, you can say that I need dead state. Okay, you can add a dead state, for example, here. Let's name it dead. Okay, and I will complete my finite state machine by drawing an arc from A to the dead state if I have initially 1, because I will not accept this one without the 0 that precedes it. Also from C, if I will have a 1 that will follow the first one, I will not accept it. So I will put an arc here from C to dead state with 1. Also from E, if I will find a 1 in the string, I will not accept it and I will go to the dead state. After these ones, also any string with 0 or 1 will not be accepted. Okay, here you are with the finite state machine with the completed transition diagram. Okay, thanks a lot.